During this session I'm going to try and explain how we can use our understanding of resistance to combine a number of different resistors and work out kind of an equivalent total resistance in both series and parallel situations. So let's start off with thinking about a series situation. If I have a series of resistors, each in series, I've got R1, R2, R3. If I carry on with some thinking and some known thinking about Ohm's law, I should be able to deduce what the total resistance is. So let me take you through those thinking steps. First of all, I'm going to recognize that the current is the same through each one of these resistors. I'm also going to recognize that for each one of these resistors there's going to be a voltage, and voltage 1 plus voltage 2 plus voltage 3 are going to equal the terminal voltage, the voltage being provided by the battery. So with that bit of thinking, let's go through those steps again. Knowing that V equals V1 plus V2 plus V3, and recognizing for each resistor that voltage is equal to the current times the resistance, I'm going to work out that the total voltage, which is total current times total resistance, is going to be equal to the current times resistance 1 plus the current times resistance 2 plus the current times resistance 3. As the current is equal throughout the circuit, it can be cancelled out, showing that the total resistance of the circuit is going to be equal to the sum of all the resistances. So the equivalent resistance is total resistance equals R1 plus R2 plus R3. So that's resistance in series. Resistance in parallel now. So I've got a series of resistors in parallel, and again I'm going to use the knowledge that I have of the circuits to try and work out exactly how I can calculate an equivalent value for all of them. Now in this situation I've got to remember that the current flowing in is going to be split into three different currents. The one consistency I have is the voltage across each one of these strands should be always identical. So let's use this thinking and work it through. So, three resistors in parallel. The three facts I work with is that the voltage across each resistor is going to be the same. The current is going to be the sum of each of the different roots. So therefore, if I think about this through, that means that the voltage divided by resistance 1 is going to equal current 1. Voltage divided by resistance 2 is going to equal current 2. And voltage divided by resistance 3 is going to equal the third option. And in total, voltage divided by the total resistance is going to equal the total current. With that in mind, I can again cancel out my voltages, which shows me that 1 over R, which is the total resistance, is going to equal to 1 over R1 plus 1 over R2 plus 1 over R3. So again, I have a solution, a way to find out any combinations. Let's think about this a little bit more carefully though. This is often a kind of a method that takes a little bit of time. There is a two resistor cheat. Okay, you can quickly find out the total resistance when two resistors are involved by doing R1 times R2 divided by R1 plus R2. So to show that example, the total resistance for this situation would be 4 times 2, which is 8, divided by 4 plus 2, which is 6, which gives me a value of 1.33 ohms as the total resistance for this circuit. Now, I've shown this cheat, and I just want you to spot something which is quite important here. Okay? Look at the resistors, and then look at the total resistance. A big thing to remember here is that when you've got a combined resistance in a circuit, parallel circuit, the total resistance is always going to be less than the smallest resistance in the parallel combination. So you're always going to get a smaller number resistance than you would do with all of the resistors you're originally working with. That's a good thing to spot when you're doing calculations. So a couple of calculations for you now. First of all, can you tell me what the total resistance is for this circuit? I'll give you a moment to think about it. And now obviously the solution here is R1 plus R2 is going to be 6 plus 34, which gives me a total resistance of 40 ohms. Right, second example, what's the total resistance in this circuit? Again, I'll give you a few moments to calculate it. Here we have the total resistance is 1 over R1 plus 1 over R2, 1 over 8 plus 1 over 6 gives me a value, and then I do 1 divided by 0.292. It gives me a total resistance of 3.4 ohms, which we notice is smaller than both of the other components. So those are the rules for calculating resistance.